we're going to look at how function transformations work, and we're going to do a bunch of transformations on the square root function, which is shown here. And as we're doing this, I really want us to pay a lot of attention to not only the mechanics of how function transformations go, but why it is that they go in this way. So one of the things that we're going to do here is that is going to help us track the process of these transformations is to look at a few key points on our graph. So in the square root function, there are several points that you should know on this graph. If you think about, what points can you list on the graph of this function? Hopefully you have at least these four: 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so this 4, 2 basically means that if I put in input value of 4, f of 4 is the square root of 4, which is 2. So the input of 4 gives you an output of 2. Input of 9 gives you an output of 3. That means f of 9 is the square root of 9. Square root of 9 is 3. So f of 9 is 3. Okay. So as we're looking at each of these transformations, we are going to track those key points. And in tracking those key points, it's really important for us to actually look at the input values. Okay, so the input values in those key points are basically the x coordinates. So those are 0, 1, 4, and 9. All right. And for no particular reason, I'm actually going to put those in list format in Desmos. There is a particular reason, but I'm not going to talk about it right now. Okay. So these are our input. These are the input values that we're going to put in to the square root function anytime we see it. Okay. So let's look at input, our transformation number 1. So here's a new function. I'm going to call it G1. I'm putting these subscripts because I have a lot of different transformations that we're going to do. And so in order to distinguish them, instead of coming up with a different letter each time, I'm just going to subscript them. So rather than G, H, K, L, I am going to call them G1, G2, G3. Okay, G1 of x is going to be 2 times the square root of x. All right, in tracking the process of this transformation, it is helpful to describe what are the instructions for G1 starting with an input value of x. So if I input an x value here, I input an x value, the first thing that I am supposed to do is I am going to square root that function, or square root that input. Okay? After I've square rooted it, then the next thing I'm going to do is I'm going to take that and I multiply it by 2. Okay. So now I'm going to actually, this is listing out what the steps are, and I'm going to take those steps and I'm going to run those steps on my key input values. Okay, so when I square root, the thing that I want to input into the square root is these key input values that I like to input into the square root function. So I'm going to copy those here. And this is the thing that I'm going to square root. So I'm going to put those numbers in, and I'm going to square root each of those numbers. So the next line is I'm going to square root each of those numbers, and those are going to be square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Okay, next thing I'm going to do is I'm going to take those and I'm going to multiply them by 2. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Okay, so this is me actually tracking an input to an output of this g function, and I'm just going to double check that if I put these input values into my function g, then I will get these output values. So if I put in the input values are 0, 1, 4, and 9. And Desmos is calculating the outputs as 0, 2, 4, and 6. And here is the here are those functions, those points graphed. And we can actually fill in now, we can fill in the graph. Oops, what just happened? We can fill in the graph, and there it is. So this is what the graph of g1 of x looks like. All right. So we could think about what is happening in this transformation. When I go and I apply the function, this is the base function square rooting. When I apply the base function and then multiply by 2, the effect of that is scaling all of the vertical coordinates by 2. Scaling all of the y coordinates by 2. Okay, so this is an interesting thing to kind of keep in mind of what is happening here, but like also keeping in mind why it's happening, like how by tracing these input values. Okay, let's close those down and look at transformation number 2. Transformation number 2, the function takes the square root of x and then subtracts 4. Okay, so we're going to go ahead and, again, describe the instructions for G2, starting with an input value. So I put in an x, and the first thing I do with that x is I take the square root of that. And now I have the square root of x, and the next thing I do is I subtract 4. All right. So I want to put those same input values in for x. I'm going to paste those same input values. I want to square root these input values. So we are tracing through the function with those key input values. So square root of 0 is 0. Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. All right. And now from each of those input values following through the next step in the function, we subtract 4. So 0 minus 4 is negative 4, and 1 minus 4 is negative 3. 2 minus 4 is negative 2, and 3 minus 4 is negative 1. Okay, so this is tracking through those input values of my function. These should be the output values of G2. And so we're going to double check letting the computer calculate the output values for these input values, 0, 1, 4, and 9. And the output values are negative 4, negative 3, negative 2, negative 1. There they are. Here are those points graphed. I'm going to change the color so they're not red. And so we can see those key points and fill in the graph. Of course, this is something that, like, if I would do it by hand, but and we can, of course, just let Desmos graph it for us, but we're tracking to actually understand what is happening here and why this is happening. So in this transformation, what we've done is we've taken our x, we've applied our base function, which is a square root, and after we applied our base function, we subtracted 4. And the effect on this is that it shifted, it basically subtracted all of the, subtracted 4 from all of the y values. So it shifted the graph down by 4, or it shifted the graph vertically by negative 4 units. All right, next transformation. So this function is you take the square, you put in your input, you square root that input, and then you subtract that, or you take the negative of that number. So let's actually, we input x, we square root that x, and then we negate, or you could also say multiply by -1. Okay, so let's put our standard inputs here. We're going to take the square root of those input values. Square root of 1 is, sorry, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3. Okay, and then we're going to multiply each of those, or take the negative of each of those numbers. So it will be 0, -1, -2, and -3. So with an input of 0, 1, 4, and 9, we should get an output of 0, -1, -2, -3. Let's put those inputs in here and see if the calculator gets the same thing. 0, 1, 4, and 9. And the outputs are 0, -1, -2, -3. And confirm by, so here are those key points there. Oh, why does it do that? And so there's our graph that goes through those key points. If we were to describe what this transformation is, you might say it is reflecting the graph across the x-axis, but I would say, this transformation is a multiplication of the y coordinates by -1 in the same way that this transformation is a multiplication of the y coordinates by 2. And multiplying by a negative has the effect of reflecting. So we are scaling the y coordinates by -1, which has an effect of reflecting across the y equals 0 line. Okay, and the y equals 0 line is the x-axis. All right. Next transformation. Now, what's this look like? Now, if we describe the instructions for this function, starting with an input value. So I take an x, I input an x, and what's the first thing I do? First thing I'm going to do is I'm going to add 5. And then after I add 5, then I'm going to square root. Okay, let's see. Okay, so this is, I take an input value, I add 5 to it, and then I square root. Okay, now I want to think a little bit more carefully about where I put my my key input values. If I put them here, if I take those key input values and then I add 5, then I have 0, 6, 9, and 14. These are the 5 more than those inputs. This is not 0. This should be a 5. All right, 5, 6, 9, and 14. Now if I square root those, that is not a happy thing for me. Like these are not the key input values for this function. These are the key input values for the square root function. So in fact, I want those to be here. Okay, those are the numbers that I want to square root. So if I want to actually square root these numbers, then what I really need to do is I need to figure out what should I input in order to get these numbers as my inputs to the square root part. Okay, so in this case, I really want to take these key input values and I want to make sure that those are the things that go into the square root, and I'm going to have to work backwards to figure out what am I going to input to x in order to put those into the square root. So I'm going to have to move in this direction. And so if I have to add 5 in order to get 0, then I must have to subtract 5 in order to figure out what input I'm going to give. So I'm going to have to add 5 in order to get 0. So I'm going to put in a -5 for x, so that when I add 5, that gives me a 0, and then I know how to square root it. And if I want to end up with a 1 after adding 5, then that means I need to subtract 5 and I need to input a -4 into my x value. I hope you're seeing this. If you are having troubles understanding where I'm coming from this, like, pause the video, go back, 30 seconds and think, like, just spend some time actually thinking about this. Okay. So if I want to input a 4 into the square root part, then I have to put in a -1 in for x. And if I want a 9 to end up as the thing that I square root, then I have to input a 4. So now let's double check. If I input these numbers in for x, then my next step in my first step in my function is to add 5. So I'm going to add 5 to -5 and I get 0. I add 5 to -4 and I get 1. I add 5 to -1 and I get 4. I add 5 to 4 and I get 9. Great. So with these input values, these are now my next step values. And from here, I can square root those numbers. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 3. And square root of 4 is 2. And square root of 9 is 3. So this says in this function, with an input value of these, I get an output value of these. So let's double check. Let the calculator calculate my outputs with that function. It's called G4, right? Yep. And so I'm going to input -5, -4, -1, and 4 into my into that function. -5, -4, -1, and 4. Okay, so that says with these input values, I get those output values. So tracking those points through the function also gets me the same outputs. And if I fill in my graph, then it does follow those 4 key points. Okay, what effect has this had on the graph? So I added a number to the input before applying the square root function. And so I added 5 to the input, and what effect that had is it actually ended up subtracting 5 from all of the x coordinates. And if you look at what we did here, you can see why we subtracted 5 from all of the x coordinates. It might seem counterintuitive at first that adding 5 means you move to the left, but that's because I had to adjust what my inputs would be so that adding 5 would get me to the same key inputs of my original function. Take a moment to absorb this and understand what's happening here. Okay. Moving on next. All right, so what are the steps, the instruction steps in this function? I take an input x. First thing is I multiply it by 3, and then I apply a square root. Okay, I input x, I multiply by 3, and then I square root. Okay, my key input values to the square root function are 0, 1, 4, and 9. I want to take the square root of those numbers, so I'm actually going to put those here. I'm not putting those in for my x, like my original input. So I know how to square root those functions, those key numbers. And I can even, no, I'm not going to do that. But I have to figure out what I need to do so that multiplying by 3 will get me to the, what should I input so that multiplying by 3 gets me to these numbers? And so that means I have to go backwards to figure out what my outputs are. If these numbers get multiplied by 3 to get here, then I take these numbers and I divide by 3 in order to figure out what my original inputs should be. So 0 divided by 3 is 0. 1 divided by 3 is 1/3. 4 divided by 3 is 4/3. And 9 divided by 3 is 3. So now, if I take these as my input values, then I would multiply them by 3, and I would get these 4 numbers. 0 times 3 is 0, 1/3 times 3 is 1, 4/3 times 3 is 4, 3 times 3 is 9. And now I take, tracking these inputs through the function, the next step would be to take the square root of those, and those are going to be 0, 1, 2, and 3. Double check that if I input these functions into my function g5, input those key values into my function g5, then that will get me to the outputs 0, 1, 2, 3. So I'm going to put in 0, 1/3, 4/3, and 3. And that gives me the outputs that I tracked through. All right, and let's fill in that graph. And what effect does this have? It looks like it stretched the graph up, but if I look at those key points here, what it has done is it has taken the x coordinates and scaled the x coordinates by 3. Sorry, not by 3, by 1/3. Okay, so we can actually write this. This scaled so multiplying the input by 3 before applying my function had the effect of scaling the x coordinates on my graph by 1/3. Okay, again, we have this sort of inverse relation between the thing that happens to the input value before applying the function versus the thing that happens to the x coordinates on the graph. All right, let's actually put this in here. This one, the effect on the graph was we added 5 to the input value before applying the function, and that meant we actually had to subtract 5 from the x coordinates. On the graph. All right. Moving on next. So what are the instructions given here? You take your input value, you negate it or multiply it by -1, and then we apply that square root function. Okay, and let's just prepare for that. I input x, oops, I missed one. So input x, and then I'm going to negate or multiply by -1, and then I'm going to square root. So this is the part where I actually want to put in that 0, 1, 4, and 9. I want to apply those key input values to the square root function. So that means I need to go back up here to figure out what my inputs are. So if I want to multiply them by -1 or take the negative of them in order to get to this point, then I have to start with the negatives of these numbers. So the negative of 0 is 0, the negative of 1 is -1, the negative of 4 is -4, and the negative of 9 is -9. In this case, the inverse function of multiplying by -1 is again multiplying by -1. Okay, so with these input values, if I negate them, if I multiply them by -1, the next step of tracking those input values through the function is 0, 1, 4, and 9. And the next step, square rooting, gives us 0, 1, 2, and 3. Okay, let's double check that if I take those input values, 0, -1, -4, and -9, and put them into my square root function, I'm going to get those output values. Oops. 0, -1, -4, and -9. And I said one thing and wrote another thing. Okay. So here are those key points transformed through the function. And there we have the filled in function. What can we say are the effects on the graph? We could say it is reflecting across the x-axis or the y-axis. But similarly to in the y-coordinates, you know, this is multiplying by -1 in the same way that in transformation 5, I was multiplying my input by 3. So I could also see this as scaling the x-coordinates by a factor of -1. Okay. All right. So I want to look at the summaries of this. If you summarize what happens, like in the first 3 transformations, I applied my base function and then I did something to the output values after applying that base function. And the effects on the graph were all effects on the y-coordinates of the graph. All right. And the last 3 transformations were doing something to the input value before applying that base function. And the effects on the graph were all inverse effects. They were inverses of the actual operation on the input. And they were happening to the x-coordinates on the graph. So I'm summarizing it like this. Any operations that happen to the outputs of output values of the function after the function is applied correspond to vertical transformations of the graph. That is, it applies to exactly the same operations on the y-coordinates of the graph. Okay, so where the transformations are consistent with the numerical operations. So if you multiply by 5 in the algebraic description of the function, then you multiply the y-coordinates by 5 on the graph. Operations that happen to the input values of the function before the function is applied correspond to horizontal transformations, that is, operations on the input, on the x-coordinates. And the transformations are inverse to the numerical operations. So multiplying x by a factor of 3 before applying the function has the effect on the graph of multiplying all of the x-coordinates by a factor of 1/3. So inverse to the numerical operations. If you add 5 to the input values before applying the function, then you subtract 5 from the x-coordinates on the graph. All right. I'm going to stop this here and I will do a couple of compound transformations in a separate video.